In this section, we're going to revert back to dealing with linear functions, just straight lines, so that we can get an idea of how inequalities in two variables work. So I've got a couple of lines or linear inequalities represented here. 3x plus 4y is less than or equal to 12, and y is greater than 2x plus 1. We can deal with them both without having to put them into a different form, but we'll see what happens when we do put them into a different form. First though, let's just find out what these things look like by graphing them with some graphing software. I'm going to use Desmos, which is a free software you can access through any web browser, desmos.com. And in Desmos you can either type things in with a keyboard, or there's a nice little pop-up keyboard if you're using an iPad, for instance. So let's just type in the first one the way it looked, which was 3x plus 4y is greater than or equal to. So we've got the greater than sign, hit more, we've got the greater than or equal to sign. Although I think it was less than or equal to. So let's hit less than or equal to 12. And you can see, we'll get the keyboard out of the way, you can see it pops up and it's got half of the plane, the xy coordinate plane, shaded. And we can pick a point anywhere in that shaded region and see if it actually generates a true statement. The easiest point of all to test is the origin. So when you replace x and y with 0, the left-hand side becomes 3 times 0 plus 4 times 0, which is just 0, which is indeed less than or equal to 12. And so that's obviously true. Now, the boundary of this is the actual line, 3x plus 4y equals 12. We can change this from a less than or equal to a less than, and watch what happens. As we change it to less than 12, the graphing software is quite clever and it changes the boundary to a dotted line. So that's indicating that along the dotted line, the left-hand side would be equal to the right-hand side. For instance, the point there, 0, 3, if you replace x with 0 and y with 3, you get 12 on the left, 12 on the right. 12 is not less than 12, and therefore that should not be part of the solution, and so you get a nice dotted line. If you take anything above or to the right of the line, let's say this point here, which is 2, 4, you're going to get something that's not true when you plug it back into the inequality. 3 times 2 is 6, 4 times 4 is 16. 6 plus 16 is clearly greater than 12, not less than 12. Alright, this is one really nice thing about graphing software, is you can type in functions that are written implicitly. In other words, they are not solved for y, which is what you have to do if you're going to use a graphing calculator like a TI-83 or TI-84. So let's take a look at the next one I had on the sheet, which was y equals 2x plus 1. So y equals 2x plus 1. Actually, it was y is greater than 2x plus 1. And so, again, we've got the line is our boundary, the line y equals 2x plus 1. Because I used a strict inequality, the boundary values are dotted. And if we plug in a point, for instance 0, 1, the y-intercept, we can see that the left-hand side is 1, the right-hand side is 1, and 1 is not greater than 1, so that should not be part of the solution. Now, it's actually pretty easy to graph linear inequalities when they're written explicitly. In other words, y is greater than something or y is less than something. Because if you have y is greater than, then you just simply draw your boundary line, and then all of the values above would obviously have a y value that is greater than the expression. And if it's y less than, let's see what happens. We'll change this to y is less than. It's going to be all the y values that are below. So it's quite easy, but if you're not sure, you can always, again, test. And the easiest point to test is the origin. The only time you wouldn't want to test the origin is when the line, the boundary values, passes right through the origin. So if you take 0, 0 and you replace y and x with 0, do you get a true statement or a false statement? In this case, 0 less than 2 times 0 plus 1. So 0 less than 1 is true, which means that's the side of the boundary line we want to be on. And indeed, that side is all shaded in. So let's go back and see what you would do if you don't have access to graphing software. All you need really is a sketch, and you could put the inequality into explicit form where you solve for y, but I'm going to do it just the way it looks by finding the x and the y intercepts. I can find the x-intercept by making y equal to 0. I get 3x equal to 12. X is therefore equal to 4. And I can find the y-intercept by making x equal to 0. If I make x equal to 0, 4y equals 12, y is equal to 3. And then I just draw a line through those 2 points. Now that's my boundary. That's the line, 3x plus 4y equals 12. And then to decide what side of the line I need to be on, I just plug in a point. And again, the origin is the easiest point to plug in. So try plugging in the origin 0, 0 and see if that makes a true statement or not. 0 plus 0 is 0, so the left-hand side is 0, and that is indeed less than 12. So you want to be on this side of the line, and you want a dark sort of solid line because this is a less than or equal to, and we want to include basically everything on the line and either below or to the left of the line. This again was 4, 0. And this was 0, 3. Now, as I said, you could solve for y. If you solved for y, you would subtract 3x from both sides. And then you would divide by 4. And get y equals negative 3 over 4x, or y is less than negative 3 over 4x plus 3. And that's the same line. The only advantage to this is that it makes it a little easier to determine which side of the line you're going to be on, because its y is less than or equal to, so it means all the y values below the line. Let's do the one on the right. We'll do a quick sketch of the line. It passes through the point 0, 1 because it has a y-intercept of 1, and it has a slope of 2, so it's a fairly steep slope. I drew a solid line, but it's not a greater than or equal to, it's just a greater than. So let's go back and draw a dotted line. That's our line, our boundary. And again, it's pretty easy when it's a greater than, when it's written, sorry, y is greater than or y is less than, because if it's y is greater than, it's all the y values above. But if you ever get confused, once again, just test the origin. So if I test the origin, 0 is greater than 0 plus 1. That is not a true statement, so I do not want to be on the side of the line that includes the origin. I want to be on the opposite side, which is the side above. You can graph on your TI-83, but I would suggest that it's better to either graph pencil and paper, or to, if you really want to find out what's going on and you're not sure, use some graphing software like Desmos or GeoGebra. You'll get much better results, and you'll be able to play around with it a lot more, and it's much more satisfying.